You know, for over a century, one single idea has pretty much dominated how we think about childhood jealousy. But what if it's just completely wrong? Today, we're going to dive into a radical new theory that reframes everything we thought we knew. It uses neuroevolution and, get this, actual math to explain something called the bioregulatory monopoly complex.
So, most of us have heard about the Oedipus complex, right? The idea that a kid's rivalry with one parent is all about desiring the other. Well, this new theory throws a wrench in that. It asks a totally different question. What if that intense, almost possessive behavior we see in kids isn't about sex at all? What if it's about something way more primal, just plain survival?
All right, so here's the game plan. First, we're going to rethink that classic theory. Then we'll introduce this idea of a survival monopoly. After that, we'll look at the actual math of stress, what a kid is really fighting for, how all this stuff shapes us as adults, and finally, we'll get to a potential solution.
Okay, section 1. So to really get this new framework, we first have to look at the old one. For decades, Freud's model has been the go-to explanation. But this new theory comes along and challenges its very foundation with, of all things, math and structure.
So here's the side-by-side, and the difference is huge. On the left, you have Freud's theory, which is all based on a psychosexual drive. The conflict is about desire. But the BRMAC, on the right, it reframes the whole thing as a survival strategy. The core conflict isn't about wanting a parent. It's about guarding a vital resource because of a deep, terrifying panic that your entire support system might just fail. It's not some phase you grow out of. It's an adaptation to a risky situation.
So let's really get to the heart of this new idea. The bioregulatory monopoly complex, or BRMC, argues that what we've been calling audible behavior is actually a totally logical, adaptive strategy that an infant uses when its survival feels like it's on the line.
And this isn't just a wild idea. It comes straight from the source thesis. The abstract itself calls the BRMC a structural mathematical alternative. It says these behaviors are adaptive resource-guarding strategies that get triggered by low-density caregiver environments. In plain English, this stuff happens when there just aren't enough caregivers to go around, specifically when that number, which the theory calls n, drops to just 2.
This quote really captures the absolute urgency of it. When a baby feels like its support system is fragile, it will try to get a complete monopoly over its main caregiver. Why? To maintain homeostasis, which is just a fancy word for keeping its internal biological system stable and safe. From the baby's point of view, this isn't a want, it's a life or death need.
Okay, this brings us to what might be the most groundbreaking part of this whole thing. The BRMC isn't just a concept, it's a formula, a way to actually calculate the risk of deep, systemic stress in a developing brain.
And here it is. This is the core formula. Systemic stress, which we'll call S, is inversely proportional to N times B. Now, what does that mean? It means the survival panic a child feels goes down as the number of caregivers, that's N, and the quality of their attention, that's B, go up.
Let's break that down real quick. S is that deep primal survival panic. N is density, the number of available, and this is key, redundant caregivers. Think about it like this. Is the baby connected to one fragile power line or a whole robust power grid? And B is behavioral quality, basically the bandwidth of their attention. Is that connection clear and fast, or is it constantly buffering?
Now, this graph shows the n variable perfectly. Look all the way to the left in what the thesis calls the nuclear zone. See how high the systemic stress is when n is only 2? But now watch what happens as you add more caregivers. You go from 2 to 4, then to 6, and the stress level just plummets. That's the inverse density law in action.
Now let's look at B, the quality variable. This graph shows what happens when n is stuck at 2 caregivers. If the behavioral quality is high, that's over on the right, the stress is actually manageable. But look what happens if that quality dips even a little bit. The stress level just skyrockets into the danger zone. It really shows you how fragile a low-density system is.
And when we put both variables together, you get this, a 3D topography of childhood stress. You can literally see the terrifying peak in the corner where both the number of caregivers, N, and their quality, B, are low. But you can also see that wide, calm, safe valley where both density and quality are high. This is the landscape the BRMC is mapping out for us.
So what is the infant actually trying to protect with this whole monopoly strategy? What are the resources it's so terrified of losing? Well, the theory points to 3 fundamental pillars of security.
First up, metabolic security, just knowing that food and warmth will consistently be there. Second is sentinel protection, that undivided gaze of a protector who is scanning for threats. And third, this is a big one, autonomic stability. A baby's nervous system can't regulate itself yet. It relies on co-regulation with a calm adult to stay balanced. These three things, they're the non-negotiable currency of survival.
Okay, and this is where it becomes incredibly relevant to all of us. The BRMC predicts that the math of our childhood, that n times b value, it doesn't just vanish. It can actually hardwire our social strategies for the rest of our lives. So here are the two paths it predicts. A childhood with a low n times b value can lead to what's called a monopoly mindset as an adult, this tendency toward possessiveness, zero-sum thinking, and anxiety. But on the other hand, a high n times b environment helps build network trust, a deep sense of security, resilience, and a much greater capacity for collaboration.
And you can see this thinking right in the source material itself, which is so cool. On the left, in the typed thesis, it predicts that a monopoly mindset leads to zero-sum thinking and relational possessiveness. And then on the right, in the author's own raw handwritten notes, you see the exact same conclusion. A low n times b value makes adults possessive, scarcity-minded, high anxiety.
All of this leads us to a really powerful and honestly, a pretty hopeful final section. Because if the problem is mathematical, then maybe the solution is too. The theory gives us a potential roadmap for fundamentally reducing developmental anxiety.
This one quote from the conclusion just sums it all up perfectly. It reframes the entire problem. If this jealous, possessive behavior is just an adaptation to scarcity, then it's not some inevitable psychological phase we all have to go through. No, it's a structural problem. And structural problems can have structural solutions.
So what's the solution?
The thesis gives a clear, testable hypothesis. To mathematically slash the probability of this anxiety taking root, the target number of reliable caregivers, n, should be 5 or more. Remember that graph we saw? 5 is the number that seems to get you out of that high-risk nuclear zone and into the broad, safe valley.
And this leaves us with a final, massive question. Let's forget psychology for a second and think bigger: sociology, urban planning, even architecture. If this formula is even remotely correct, what would our world look like if we intentionally designed our communities to create high n times b environments for every single child? What would change?